All right, lesson 2.11. 2.11 is about finding intersections. 11.1, when F meets G. This is your warm-up. And the warm-up says mentally identify a point. So when we're talking about a point is X comma Y, an order pair, X comma Y, where the graphs of the two functions intersect. So that's an important word here, intersect. If one exists. One of these four options, 1, 2, 3, or 4, is not going to have an intersection. Just so you know, only one of them. And the idea here is that you don't graph them, but feel free to check your solution by you could go to Desmos at the end. You go to Desmos and you could graph these. So for example, on Desmos you could just put y equals x. It'll graph you a line, and then you could put y equals 3, and it'll graph. And if you remember from Algebra 1, a topic called systems of equations from Algebra 1, if you have a graph and then you graph another one, remember right here is very important in systems. Wherever they cross each other or they intersect, that is your solution to the system, and it's a point x comma y. All right, so whenever you have two graphs, they don't have to be lines. Whenever you have two lines and they intersect, that's where the solution is at. So one way of doing it, don't worry about the mentally part here, but what this warm-up is asking for is the following. So you have two equations. One of them is called f of x, the other one is called g of x. Let me do my work over here. So one of them is called f of x, but I could just replace it and put y equals x, and the second equation is y equals 3. Okay? If you want to know where they intersect, then you set them equal to each other. Okay, I'm going to say that again. When you want to know where two graphs intersect, you set the equations equal to each other. So they're already equal to y, but if you set them equal to each other, then what's going to happen is a new equation is created called x equals 3. This means that the graph is going to cross at x equals 3. We have half the problem already because we need to find a point x comma y and an order pair. So we already know that they're going to cross at 3, but what about the y value? So if you want to know the y value, what you're going to do is you're going to substitute your x value, plug it into the original equation. So if you take this 3 and you plug it into the x, so instead of plugging x here, you plug in 3. So that means that your y coordinate is going to be y equals 3. So that's where they would cross. And this is going to be evident if you go to Desmos. This is what you do at the end. You don't need to do this at the beginning. You put y equals x, and you get a graph like this. Y equals 3 is this blue graph here. And look at what's happening here. They both both lines intersect at 3 and 3. So this point here is 3 comma 3. And that's what we came up with in the uh, that's what we came up with right here. Okay, so that's what this lesson is about. You're looking for points where the graphs intersect, but without actually graphing them. Showing this by algebraically. Let's let me do 3. Let me do this one right here. Let me erase this work here. For the warm up, no. For the if you the question is if you have to show your work for these, yes, but it's the same idea. For the warm up is not necessary. In fact, there's not a lot of space here to show, right? But on 11.2, there is space there because you are. I'm going to show you how to do it, and there's some steps in the middle that are important. Okay. So let me do number 3, and then I'll show you how to do 11.2. So number 3, or this one, m of x. I have two equations. One of them is called m of x, and the other one is called n of x. I should write down the steps somewhere. I'll write down the steps somewhere in a little bit. Maybe I'll write it down right here. So the first thing that we're doing, step number 1, set the equations equal to each other. If you want to know where the graphs intersect, you set them equal to each other. So this is going to be x plus 3, x minus 3 equals to the other graph, x minus 3. Okay, you see how I'm setting them equal to each other? Step number 1, set them equal to each other. Step number 2, set the equation equal to 0. So we want to know where the graphs are going to intersect each other, so I have to solve for x. Just like I did over the first one was easier because there was really no algebra to do here. But on this one has a lot more information. So we're gonna try to solve for x. Okay, so in order to do that, I'm gonna set the equation equal to 0. So this is x plus 3, x minus 3. These are connected by a times. And then I subtracted that other parentheses to the left side. Okay, so I moved this to this side. I subtracted it, and I got a negative or minus parentheses x minus 3. All right, so I move it over, and now I have this. Here I could do a GCF. So this is one of the reasons why we spend 2 days on factoring, reviewing factoring, because it's going to come in right now. You have this. If you look at this part and this part, you ask yourself, what do they have in common? Well, they have an x minus 3 in common. So you take that out and you leave whatever's inside. So the x plus 3 you didn't touch, so you leave it inside. Minus, if you factor this out, there's a 1 right there. There's a 1 right here. So you leave it in there, equal to 0. Now let me do a little bit of work in here. There's a little parenthesis there. I could just get rid of it and combine like terms. So this becomes x plus 3 minus 1. I could do 3 minus 1 here. and this becomes x plus 2. And I have this bracket here. I could just turn it into a parenthesis. And the original GCF that I took out, I bring it down, and this is equal to 0. Here, you should know how to solve for x. The zero product property tells me that one of the x-intercepts is going to be, or one of the solutions is going to be positive 3, because 3 minus 3 is 0. And the other solution is going to be negative 2. So negative 2 plus 2 is 0. So you have one x value and another x value. Okay, but remember that the problem is not done here, because I want to find x comma y. I'm missing the y value. So this is how you find the y value. This is 3, by the way, and this is negative 2. Okay, so to find the y value, what you're gonna do is take this x and plug it into any of the equations. Plug it into the one that looks easy. So you could either plug it into to this side here or to this side, and you could tell that the n of x has less information, so you could just plug them in here to the x. This is getting a little messy here, but so the one that has n of x is y equals x minus 3, which is this one. So now plug in 3 right here. Plug in x equals 3, plug it in there. That would be 3 minus 3. So that's 0. So this is going to be 0. And then take negative 2. Take negative 2 and plug it in there to the x. Substitute it. So that would be y equals negative 2 minus 3. That will be negative 5. So let me go back to my question. And the 2 points where they cross is 3 comma 0 and negative 2 comma negative 5. I did a whole lot of work here, but this is just to get us starting. Sometimes you could see these numbers mentally. Let's confirm what these two numbers represent. I'm gonna go to Desmos, and you're gonna see that the graphs are gonna intersect. Hopefully they intersect at these 2 points. So here it is, look. Okay, so one equation is x plus 3, and the other one is y. I think it's plus 3 as well. Minus 3. Okay. So you see that I graphed both of them. The one with the 2 parentheses, since it's a degree 2, you see that it's an even function, so it goes up. It's like a parabola, or it is a parabola or a quadratic. And the bottom one, it's a linear, because it's in the form of y equals mx plus b. So it crosses, and you see the graph. This point is going to be 3 comma 0, and this point is going to be negative 1, negative 2. So it's negative 2 comma negative 5. So that's what we found algebraically doing all this writing over here. If you need to take a screenshot of this, go ahead and do so, because I'm going to erase this part so I could give you an example of 11.2. Okay, 11.2 is the same thing, more points of intersection. Let's do number 1. Okay, so number 1, if you want to find the points of intersection, you set the equations equal to each other. So this becomes x squared minus 7 equals to 2. We're trying to solve for x. You could technically do some mental math here, and you're thinking what number squared, and then you take away 7 gives you 2, right? You could take it from there, or set the equation equal to 0 so that maybe it becomes easier. So take minus 2 and minus 2. These are like terms. So we're looking at x squared minus 7, no, minus 9. X squared minus 9 equals 0. And from right here, it should be pretty evident that a number squared minus 9 equals 0. I'm thinking about 3, right? 3 squared. 3 squared minus 9 is 0. So one of the answers is going to be x equals 3, right? Because you're thinking what number squared minus 9? And there's another number that when you square it and you take away 9, it gives you 0. That would be negative 3. Negative 3 squared is 9, and 9 minus 9 is 0. So my two solutions are going to be 3 and negative 3. Say you don't like the mental math here. Another thing you could do here is factor. This is a difference of squares. You should recognize that this is a difference of squares. So if you factor it, x squared is a perfect square, so you put x times x. There is a subtraction sign, and the 9 is a perfect square, so you're going to put 3 and 3. And then remember that difference of squares, you get one of each sign, and the order doesn't matter. So from this parentheses, you would get x equals negative 3, and for this parentheses, you would get x equals 3. Okay, right here I did factoring, but you could have gotten that through some mental math right here. All right, and remember the final answer is not 3 and negative 3. We need to find the y coordinate. What is the y value? So consider both of your graphs, and you're going to plug in your x values to one of the equations. There's nothing to plug in on d of x, so our focus is going to be on c of x. So let's take y y equals x squared minus 7. So right here in the parentheses, you're gonna plug in 3 and negative 3. So if we start with 3, that would be 9 minus 7. 9 minus 7. So that would be 2. So one of the order pairs is going to be 3 comma 2. Now for negative 3, let's do negative 3. If I plug in negative 3 there, that is still positive 9. Minus 7 is still 2. So those are your 2 points of intersection. 3 comma 2 and negative 3 comma 2. I'm not going to show you the graph on Desmos, but if you want to see visually what this looks like, you could punch those equations into Desmos and you should expect that they cross at 2 spots, in these 2 spots. The last example is number 3. Step number 1, set both equations equal to each other. Okay. I typed in the steps right here. It's step number 1, you set the equations equal to each other. We did that. Step number 2, set the equation equal to 0. So I need to move everything around so that it's equal to 0. Okay, so then this would be x plus 7, x minus 4, minus 2x plus 5, x minus 4 equals to 0. So I moved these 2 parentheses over to the left side by subtracting them. Okay. Now, there are, if I'm looking for a GCF, none of the parentheses, they don't have any parentheses in common. So this becomes you will need to multiply here. So take these 2 parentheses. Actually, let me see if I could do anything else. I could see that one of the answers is going to be 4, because 4 minus 4 is 0. And also over here, 4 minus 4 is 0. Oh, wait, they do have something in common. I didn't see that. They have an x minus 4. So I could take that out. You see that? They have an x minus 4, so I'm going to factor that out. And then inside these brackets, I'm going to put whatever they didn't whatever I didn't use. So x plus 7 is still there, minus 2x plus 5. That's by taking out a great common factor, which is the x minus 4. I take it out, and then in brackets, I put whatever I didn't use. So you have these two parentheses. Now in here, I could just combine like terms. I could drop the parentheses. So this becomes x plus 7, and then this negative, this subtraction, I'm going to distribute it inside, so it becomes negative 2x minus 5. Okay, let's combine like terms right here. This is 1x minus 2x is negative 1x, and then 7 minus 5 is 2. Okay, and from here, if I use the zero product property, now I could see that my answer is going to be, one answer is going to be 4, because 4 minus 4 is 0, and the other answer, this one's a little, it's, you have a negative in the front, so take that into account. So if you want to do this, you could set it equal to 0, subtract 2 from both sides, and then there's a negative 1 here, so you have to divide by negative 1. So this becomes x equals positive 2. X equals positive 2. So I have x equals 4 and x equals 2 as the possible points of intersection. And step 4 of the problem, you got to find the y coordinate by substituting the x value. So you're going to take 4 and plug it into either the m of x or the n of x. It doesn't matter. So let's plug it into, say, the m of x. Okay, so if you take 4 and you plug it in, what you're going to see is that this is going to be 4 and 4. That would be 4 minus 4 is 0. And 0 times whatever this is still going to be 0. So the y coordinate when you plug in 4 is going to be 0. And do the same thing by substituting the 2. So let's see, that would be 2 plus 7 and 2 minus 4. So this is 9 times 2 minus 4 is negative 2. So you get negative 18. There was a whole lot of concepts in this problem, but that's how you do number 3.